So now I'm going to show you how to find the solution of the equation x to the 4 minus 2x cubed plus 5x squared minus 6 is equal to 0 using the Newton iteration and the initial value of 1. Newton method is basically an iteration that we use the old approximation to find the new approximation. So basically we use the output of the first iteration to be the input of this next iteration. So in order to use the Newton method here, we have to save the initial value on the calculator first. My initial value is 1, so I hit 1 and I hit enter. By doing so, my number 1, the initial value, has been stored to the answer on the calculator. Now in order to record the answer, we have to hit second ans. So now the value of ans here is 1, right? And I try to finish the iteration of Newton methods. So I have subtract and I open a parenthesis. In this parenthesis, I'm going to enter the f function at ans. The function is x to the 4, so here I'm going to enter answer to the 4. So second ans to the 4. And then subtract 2 second ans cube. Hold up. I think we have to time here. Times second ans cube. And then plus 5 times x squared, which is second ans squared. Then minus 6. So this is the f function. And then divided by, open another parenthesis. In this parenthesis, we are going to enter the derivative of the function at ans. The first derivative is 4x cubed minus 6x squared plus 10x. So I'm going to have 4 times answers cube minus 6 times answer squared plus 10 times answer. And then close the parenthesis. So this is the iteration methods, right? And when we hit enter, we will have the first approximation, which is 1.25. And now 1.25 is stored into ans instead of 1. You see that at first we save 1 into ans, but after one iteration, the new value of ans is the first approximation 1.25. Now we don't have to repeat, we just have to hit enter one more time. You see that? So I repeat, for the next step, we just have to hit enter. Continue to hit enter. So at 2, the second approximation here is 1.2182142886. And we continue to hit enter. We have the next approximation. So let's see, 1 is x0, 1.25 is x1, 1.218 something is x2, and then x3. And the question asks you to find a solution correct to 6 decimal places. So we basically continue to hit enter until we see that the first 6 digits after the decimal are repeated. So let's see. If we hit enter one more time, we compare these two numbers. What do we have here? we have 2, 1, 7, 5, 6, 2 are repeated. You see that? So we have 6 digits after the decimal are repeated. So this is the solution that is correct up to 6 decimal places. So the answer of this question is 1.217562. That is the answer. If we compare the third approximation and the fourth approximation, we see we have only 2 numbers after the decimal are repeated. So it's correct to only 2 decimal places. But we want to have the solution that is correct up to 6 decimal places. So we have to continue the iteration by continue hitting enter until we see there are 6 digits after decimal are repeated. So the answer here is 1.217562. So that's how we use Newton iteration on calculator TI-A4.